Before the concept of time existed, before the universe stretched its arms across the void, there was nothing. Only an infinite silence shrouded in incomprehensible darkness. For centuries, humanity has looked into the night sky, wondering what lies beyond the faint light of the stars. The cosmos, a realm both beautiful and terrifying, has always been full of unanswered questions. But one question has stood above them all. Does the universe have an edge? The idea of a boundary for the universe is one that has haunted humankind for millennia. From ancient myths to modern science, the belief in a cosmic frontier has captivated our imaginations. Ancient civilizations were among the first to wrestle with this question, their understanding of the cosmos bound by mythology and observation. The Babylonians envisioned a flat earth surrounded by an endless ocean. The Greeks, influenced by thinkers like Aristotle, believed the stars revolved within crystalline spheres enclosing our planet. Even as we pushed beyond these early ideas, the longing to understand the edges of existence persisted. When Galileo first turned his telescope to the heavens in 1609, he shattered the illusion of a perfect, unchanging cosmos. He saw craters on the moons of Jupiter, and countless stars beyond the naked eye's reach. Yet while he expanded the boundaries of our known universe, the question of an edge remained unanswered. If the stars extended infinitely, did space itself go on forever? Or was there a place where it all stopped, a cosmic wall that no one could see? Fast forward to the 20th century, when our understanding of the cosmos was revolutionized by one man, Edwin Hubble. Through painstaking observations, Hubble discovered that galaxies were not static, they were moving away from us. This discovery, known as the expansion of the universe, was monumental. For the first time, humanity understood that the universe was not fixed, but dynamic, stretching outward in all directions. This revelation brought with it new mysteries. If the universe is expanding, what is it expanding into? Does that mean there is a limit, an edge, where space itself ends? To understand the edge of the universe, scientists first had to confront the concept of infinity. Is the universe truly boundless, or does it have a finite structure? If it is finite, does that mean there's something beyond it? These questions weren't just philosophical, they were scientific challenges that required answers. In the mid-20th century, astronomers began mapping the cosmos, using powerful telescopes to chart the locations of stars and galaxies. As they mapped deeper and deeper into space, they found that the universe was far larger than anyone had imagined. But no matter how far they looked, there was always more. One of the most significant breakthroughs came in 1965, with the discovery of the cosmic microwave background radiation. This faint, omnipresent glow is the remnant of the Big Bang, the birth of the universe itself. By studying this radiation, scientists could peer back in time to the very beginning of existence. It was like finding the faint echoes of a distant explosion, a clue to the origin of everything. The discovery of the cosmic microwave background not only confirmed the Big Bang theory, but also provided a way to measure the size and shape of the universe. Scientists learned that the universe is not infinite but finite, with a specific size and curvature. This revelation raised even more questions. If the universe is finite, does that mean it has an edge? The answer, as it turns out, is more complicated than anyone expected. The universe is finite in size, but it has no edge, at least not in the way we think of edges. Imagine the surface of a sphere, like a balloon. It's finite, but you can travel around it endlessly without ever encountering a boundary. This is how scientists describe the universe: finite but unbounded. But what does that mean for the edge of the universe? And could we ever find it? The search for the edge of the universe is as much about time as it is about space. When we look at distant galaxies, we're not seeing them as they are now, but as they were billions of years ago. Light takes time to travel, and the farther we look, the older the light we see. At a certain point, we reach a limit. the light from the earliest moments of the universe, just after the Big Bang. Beyond this, there is nothing to see. Not because there's nothing there, but because the light hasn't had enough time to reach us. This concept, the observable universe, is a key part of understanding the edge of the universe. The observable universe is not the entire universe, it's just the part we can see. Beyond it lies a vast, unobservable expanse, a realm of mystery and speculation. Some scientists believe that the universe may be infinite, stretching on forever. Others suggest that it is part of a multiverse, a collection of many universes existing side by side. If this is true, then the edge of our universe might not be a boundary at all, but a gateway to something far stranger. The Hubble Space Telescope, launched in 1990, was a game-changer in the search for the edge of the universe. With its powerful lenses, Hubble could peer deeper into space than any telescope before it, capturing images of galaxies billions of light-years away. These images, known as the Hubble Deep Field, showed us a universe teeming with galaxies, each containing billions of stars. The deeper we looked, the more galaxies we found, stretching across an unfathomable expanse of space. And yet, even Hubble had its limits. No matter how far it looked, it could never reach the true edge of the universe. In recent years, new technologies have taken us even closer to the edge. The James Webb Space Telescope, launched in 2021, is designed to look even farther back in time, capturing the faint light of the first galaxies. By studying this light, scientists hope to answer some of the most profound questions about the universe. How did it begin? How will it end? And what lies beyond its boundaries? But as we push the limits of observation, we are confronted with a troubling possibility. The edge of the universe may be forever out of reach. Not because it doesn't exist, but because of the nature of space and time itself. The universe is expanding, and the rate of expansion is accelerating. This means that the most distant galaxies are moving away from us faster than the speed of light. Their light will never reach us, no matter how long we wait. The edge of the universe is not a wall or a boundary. It's a horizon that recedes as we approach it, a mirage that will always remain just out of reach. Throughout history, the quest to understand the universe has pushed humanity to its intellectual limits. With every answer came 1,000 new questions, but few have been as tantalizing as the idea of the universe having an edge. What exactly would an edge look like? Is it a physical boundary, a void beyond comprehension, or something more elusive, a limit imposed by the fabric of space-time itself? To understand this mystery, scientists had to first unravel the structure of the universe and the forces that govern it. This is the story of cosmic geometry, the great expansion, and the tools we've developed to see the unseen. The shape of the universe is one of the most profound questions in modern cosmology. Is the universe infinite, stretching endlessly in all directions? Or is it finite, with a specific size and shape? If it is finite, does that imply the existence of an edge? The answer lies in the geometry of space itself. Einstein's theory of general relativity, published in 1915, revolutionized our understanding of the cosmos. According to Einstein, space is not a static, empty void, but a dynamic, malleable fabric that can bend and stretch under the influence of gravity. This idea of space-time curvature paved the way for understanding the large-scale structure of the universe. Imagine a flat sheet of paper. This is how we might intuitively imagine space, endless and unchanging. Now imagine that paper being curved into a sphere. The surface of the sphere is still finite, but it has no edges. You can travel around it endlessly. This analogy helped scientists conceptualize how the universe could be finite, yet unbounded. By studying the cosmic microwave background radiation, the faint afterglow of the Big Bang, scientists were able to measure the curvature of the universe. The results were staggering. The universe is flat, but on a cosmic scale, it is likely finite. If the universe were infinite, it would lead to paradoxes, such as infinite stars shining infinitely brightly, a concept known as Olber's paradox. Instead, the finite nature of the universe gives it structure and boundaries, even if those boundaries are not physical walls. Visualize this concept. Picture a balloon expanding as dots on its surface spread apart. The discovery that the universe is expanding was one of the most groundbreaking moments in scientific history. In the 1920s, Edwin Hubble observed that distant galaxies were moving away from us. Their light stretched to longer, redder wavelengths, a phenomenon known as redshift. This was the first evidence that space itself was stretching, carrying galaxies along with it. But what does this mean for the edge of the universe? If space is expanding, what is it expanding into? The answer, as strange as it may seem, is nothing. Space doesn't expand into anything because it isn't expanding in the way we think of objects expanding in a room. Instead, the universe is creating more space as it expands. This means there is no outside of the universe, at least not in a sense we can comprehend. The edge of the universe, then, isn't a physical location, but a limit imposed by the speed of light and the finite age of the universe. But what if there's more to this story? What if the edge isn't just a limit of distance, but of time itself? To understand the edge of the universe, we must first understand the concept of the observable universe. The observable universe is the portion of the cosmos we can see, limited by the speed of light and the age of the universe. Light from distant objects takes time to reach us, billions of years in fact. The farthest objects we can see are those whose light has been traveling toward us since the beginning of time. But beyond this lies the unobservable universe, a realm we can never reach or even confirm exists. This is the true edge of the universe as we know it, not a boundary, but a horizon. As we look farther and farther into space, we are looking further and further into the past, approaching the moment of the Big Bang itself. The observable universe is estimated to be about 93 billion light-years in diameter, but the actual universe is likely much larger, possibly infinite. Scientists can only speculate about what lies beyond the observable horizon, but theories range from infinite expanses of similar galaxies to entirely different physical laws and dimensions. Light plays a critical role in defining the edge of the universe. Because light travels at a finite speed, about 186,000 miles per second, it acts as a cosmic time machine, allowing us to see objects as they were billions of years ago. But this speed also imposes a limit. The farthest light we can see is from objects whose light began traveling toward us 13.8 billion years ago, just after the Big Bang. As the universe expands, some objects are moving away from us faster than the speed of light due to the stretching of space. These objects are beyond our reach, their light forever trapped in the unobservable universe. This means that the edge of the universe is not a fixed point, but a moving target, constantly receding as the universe grows. Subscribe to Frontiers of Infinity to explore more mysteries like this, because the universe is bigger than we can imagine. In 1998, scientists made a shocking discovery. The universe's expansion is accelerating. This mysterious phenomenon is attributed to dark energy, an invisible force that makes up about 68% of the universe. Dark energy pushes galaxies apart, stretching space faster and faster. The discovery of dark energy changed everything we thought we knew about the universe. If the expansion continues to accelerate, the most distant galaxies will eventually disappear from view, leaving us in an increasingly empty universe. This raises profound questions about the fate of the cosmos and our place within it. What lies beyond the edge of the universe? Could there be other universes, parallel realities, or dimensions beyond our comprehension? Or is the edge simply the limit of our understanding, a boundary imposed by our own perception of space and time? As we delve deeper into the mysteries of the cosmos, we are confronted with the humbling realization that the universe is not only vast, but filled with enigmas we may never solve. The edge of the universe, if it exists, is not just a physical boundary, but a philosophical one. A reminder of the limits of human knowledge and the infinite potential for discovery. In the next section, we will explore how scientists have used cutting-edge technology to probe the furthest reaches of the cosmos, uncovering clues about the nature of existence itself. Stay tuned as we journey beyond the edge of the observable universe. Join us every Friday at 7 p.m. ET as we unravel the darkest secrets of the cosmos, only on Frontiers of Infinity. For much of human history, the universe was thought to be small, static, and bound by the heavens above. The idea of vast expanding galaxies or an edge to the cosmos was unimaginable. Yet, the 20th century ushered in a scientific revolution, one that would forever change how we perceive our place in the universe. This is the story of how humanity uncovered the secrets of the cosmos's outermost reaches. The quest to discover the edge of the universe began with humble tools and ambitious minds. The invention of the telescope in the early 1600s allowed astronomers like Galileo Galilei and Johannes Kepler to see the universe in unprecedented detail. Yet, even with these advances, the cosmos appeared to be little more than a fixed collection of stars, scattered like grains of sand across a black canvas. It wasn't until the 20th century, with the advent of spectroscopy, that scientists began to truly understand the nature of the stars and galaxies. Spectroscopy, analyzing the light emitted or absorbed by objects, allowed astronomers to determine the composition, temperature, and motion of celestial bodies. This technique revealed something astonishing. Many galaxies were moving away from us, their light stretched into red wavelengths. This phenomenon, known as redshift, became the first clue that the universe was expanding. Edwin Hubble's work at the Mount Wilson Observatory in the 1920s was pivotal. By measuring the redshift of galaxies, Hubble discovered a direct correlation between a galaxy's distance from Earth and its velocity. The farther away a galaxy is, the faster it moves. This became known as Hubble's law, a cornerstone of modern cosmology. But what did this expansion mean for the universe as a whole? If galaxies are moving apart, they must have once been closer together. This led to the groundbreaking theory of the Big Bang, a singular moment when the universe burst into existence, expanding from an unimaginably dense and hot state. While Edwin Hubble's discoveries set the stage, it wasn't until the launch of the Hubble Space Telescope in 1990 that humanity truly began to explore the edges of the universe. Orbiting high above Earth's atmosphere, the Hubble telescope provided a crystal-clear view of the cosmos, free from the distortions caused by air and weather. One of Hubble's most famous achievements was the creation of the Hubble Deep Field, an image capturing thousands of galaxies in a tiny patch of sky no larger than a grain of sand held at arm's length. This image revealed galaxies so distant that their light had taken billions of years to reach us. For the first time, humanity was looking at the universe as it appeared shortly after the Big Bang. But even with its extraordinary capabilities, Hubble could only see so far. The light from the most distant galaxies had been stretched so much by the universe's expansion that it fell into the infrared spectrum, invisible to Hubble's instruments. To see beyond this limit, scientists needed a new tool. In 2021, the James Webb Space Telescope, JWST, was launched, promising to revolutionize our understanding of the cosmos. Unlike Hubble, which primarily observes visible and ultraviolet light, the JWST is designed to detect infrared light, allowing it to peer deeper into the universe's history than ever before. The JWST's ability to observe faint, distant galaxies has already yielded groundbreaking discoveries. By studying the light from these ancient galaxies, scientists can learn about the universe's earliest moments, when stars and galaxies were just beginning to form. These observations bring us ever closer to the edge of the observable universe, a horizon that marks the limit of what we can see, dictated by the speed of light and the age of the cosmos. But even as we push the boundaries of observation, the true edge of the universe remains elusive. The universe's expansion means that some regions are moving away from us faster than the speed of light. Their light will never reach us, no matter how advanced our technology becomes. This creates a cosmic event horizon, a boundary beyond which lies the unobservable universe. But what if there's more beyond this horizon? What if the edge of the universe isn't the end, but a gateway to something unimaginable? One of the most critical tools in uncovering the edge of the universe is the cosmic microwave background radiation, CMB, a faint glow that permeates the cosmos, left over from the Big Bang. Discovered in 1965 by Arno Penzias and Robert Wilson, the CMB is like a photograph of the universe when it was just 380,000 years old. By analyzing tiny variations in the CMB, scientists have been able to map the universe's structure, measure its age, and determine its rate of expansion. This data has also confirmed that the universe is finite but unbounded, with a flat geometry on large scales. The CMB provides a glimpse of the universe's outermost reaches, but it also raises profound questions. What existed before the Big Bang, and what lies beyond the observable universe? As we approach the limits of the observable universe, one theory looms large: the multiverse. Could our universe be just one of many? A bubble in a vast cosmic foam? If so, the edge of our universe might not be an end, but a doorway to other realities. The multiverse theory, while still speculative, is supported by certain interpretations of quantum mechanics and string theory. These theories suggest that different regions of the cosmos could have different physical laws, dimensions, and even forms of life. If the multiverse exists, then the true edge of our universe is not a wall but a bridge, a transition from one reality to another. Subscribe to Frontiers of Infinity and join us as we explore these mind-bending possibilities every Friday night. As we've seen, the discovery of the universe's edge is not a single moment, but an ongoing journey, one that pushes the boundaries of human understanding and technology. From the redshift of galaxies to the faint glow of the cosmic microwave background, every discovery brings us closer to answering the ultimate question: what lies beyond? But as we approach the limits of observation, we are reminded that the universe is not just a physical place. It is a realm of infinite possibilities and mysteries. The edge of the universe is not an end, but a beginning, a horizon that beckons us to explore, to question, and to dream. In the final section of this journey, we will confront the greatest mysteries of all. What lies beyond the edge? And what does the future hold for humanity as we continue to unravel the secrets of the cosmos? Stay tuned as we venture into the unknown. What lies beyond the edge of the universe? It is a question that humankind has pondered for centuries, a riddle that haunts the minds of scientists and dreamers alike. We have peered deeper into the cosmos than ever before, unraveling its secrets layer by layer. Yet, as our understanding grows, so too does the magnitude of the unknown. For every answer the universe gives us, it whispers 1,000 more questions into the void. The edge of the observable universe is not an end. It is a beginning. It is a gateway to realms we cannot see, to dimensions we cannot touch, and to truths that defy our comprehension. But what do we know of this edge, and what lies beyond it? When we talk about the edge of the universe, we are not speaking of a physical barrier or a cosmic wall. Instead, we are describing a horizon, the point at which time and space conspire to keep us from seeing further. This horizon is shaped by the speed of light, the universe's expansion, and the finite age of the cosmos. Light from the most distant galaxies has been traveling for 13.8 billion years to reach us. Beyond this point, the light has yet to arrive, leaving us blind to what lies farther away. The edge of the observable universe is, in essence, a limit of time. It is the oldest light, the faintest echoes of the Big Bang itself, stretching across a vast and silent cosmos. But what if we could break through this barrier? What if there were a way to see beyond the light, to peer into the realm where time itself began. Some scientists believe that quantum mechanics, the strange and unpredictable rules governing the smallest particles in the universe, may hold the key. As we gaze outward into the universe, we must accept one humbling truth. We are blind to the majority of existence. The observable universe is only a fraction of the whole, a tiny bubble floating in an ocean of cosmic possibility. What lies beyond the observable universe? Theories abound, each more tantalizing than the last. Some suggest that space stretches infinitely, filled with countless galaxies, stars, and planets, all beyond our reach. Others propose a multiverse, a collection of universes existing side by side, each with its own physical laws, dimensions, and realities. If true, the edge of our universe is not a boundary, but a bridge to other realms. And then there are the darker possibilities. Realms where the rules of physics break down, where time loops endlessly, or where existence itself dissolves into chaos. Beyond the edge may lie a place where the universe forgets itself, a realm where nothing and everything coexist in eternal silence. But perhaps the most haunting question is not what lies beyond, but why the universe is hidden from us in the first place. The edge of the universe forces us to confront the nature of the void itself. What is nothingness? Is it simply the absence of matter, or is it something more? Scientists have discovered that the vacuum of space is not truly empty. It is seething with quantum energy, a roiling sea of particles that appear and disappear in an instant. This quantum foam may be the foundation of reality itself, a chaotic tapestry from which the universe was born. Could the void beyond the edge be a window into the quantum realm, a place where the rules of existence are rewritten? Or is it the ultimate end, a silence so absolute that even time cannot endure? The answers lie not in what we see, but in what we cannot. As we grapple with the mysteries of the edge, we must also consider the ultimate fate of the universe. Scientists have proposed 3 possible endings, each as haunting as the last: the Big Freeze. The universe continues to expand, its galaxies drifting further apart until the stars burn out, leaving a cold, dark void. The Big Crunch. Gravity reverses the expansion, causing the universe to collapse in on itself, returning to the dense state from which it began. The Big Rip. Dark energy accelerates the expansion to such an extent that the fabric of space-time is torn apart, destroying everything in its path. Each scenario points to an inevitable truth. The universe, like all things, will one day come to an end. But what lies beyond that end? Could the death of the universe give birth to another, as some theories suggest? If so, then the edge of the universe is not a limit but a cycle, a perpetual dance of creation and destruction. And if the universe can be reborn, what does that mean for us? The edge of the universe is not just a place. It is a concept, a challenge, and a promise. It is a reminder that the cosmos is far larger and stranger than we can imagine. As technology advances, we may one day pierce the veil of the unobservable, uncovering secrets that have eluded us for eons. Already, scientists are planning the next generation of telescopes, capable of peering even deeper into the universe's history. Missions like the Nancy Grace Roman Space Telescope and projects exploring gravitational waves could reveal the faint whispers of cosmic events beyond our current reach. But even as we push the boundaries of observation, we must confront the ultimate truth. The edge of the universe may be unknowable. The cosmos is not obligated to reveal its secrets, and some mysteries may remain forever beyond our grasp. Yet it is this very uncertainty that drives us to explore, to question, and to dream. As we conclude this journey, we are left with more questions than answers. What lies beyond the edge of the universe? Is it a gateway to other realms, a void of infinite silence, or something else entirely? And what does our search for the edge reveal about ourselves? The universe is a mirror, reflecting our deepest fears and greatest hopes. It challenges us to confront the unknown, to embrace the mysteries that lie beyond the horizon. In the end, the edge of the universe is not just a place, it is a story, one that we are only beginning to write. As we stare into the vastness of space, we are reminded of a simple yet profound truth. The universe is not just out there, it is within us. It is in our questions, our dreams, and our endless desire to understand. The edge of the universe is not an end, but an invitation to wonder, to explore, and to imagine what lies beyond. Join us next Friday at 7 p.m. ET for the next episode of Frontiers of Infinity, where we unravel the darkest mysteries of space.